Today we're going to take this pile of parts and turn it into one of the rarest and most versatile bench vises you've probably ever seen, the Emmert Universal Bench Vise. We're going to do some cleaning up of the body, a little bit of machining to make some parts, some jaw surgery, and a few other things to get this thing back in service. And we're going to start out using some WD-40 Specialist Rust Removing Soak to clean this thing up. Thank you to WD-40 brand for sponsoring this video. I've really enjoyed using the WD-40 Specialist Rust Removing Soak. It's a really clean and easy way to remove surface rust. And when I bought this vise, it had been sitting on the floor of a workshop for quite some time in pieces just like this. So it definitely was the perfect candidate to soak in these buckets of this solution for a couple of days to remove all the surface rust. The trickiest part I have found with using this product is just getting a vessel large enough for some of my tools. But you can see the liquid has turned like a grayish black color. That's that rust coming off of it. And by pulling out the parts, you can already tell how much cleaner they are. This stuff is amazing at the way that it removes rust without really any effort. So once you get all the parts out of the solution, you can actually reuse it. So I'm pouring it into a larger bucket that I can kind of reuse and put larger parts in. And then you want to actually wash the stuff off with just clean water. It's important, though, that you dry these parts after you wash them because you just removed all that rust. And if you leave the water on there, there is a potential for them to flash rust. There is a WD-40 Specialist Rust Inhibitor Spray you can use, but since this is going to be painted, I went ahead and skipped that step. So you can see all the parts, how clean they are, that nice gray color, and I let them dry thoroughly. And then, unfortunately, I put this project on hold for about a month. So once I dried everything off, these parts sat on the floor of my shop, and now we're going to pick back up where we left off. And you can see from leaving them, they have a little bit of surface rust on them, but that's no problem. It's basically just from the humidity in my shop in the summer. And I'm going to start this off with a little bit of a test assembly. And this is going to give you a good idea of the different components that go into this vise. So it's actually a really complicated design for something that was made over 100 years ago. There's actually a marking on this vise that I'll show you later from the original owner who dated it 1911. Which is pretty incredible to think that this thing survived basically fully intact. So it uses a various type of components that you can see to kind of keep the jaws in place and keep everything rotating. And one of the weird things is that I've found that the casting is off on one of the jaws, but that's okay. We're going to correct that. You can see there are pin jaws, there are machine jaws, and then there are flat jaws. And this is the only vise in my shop that has 3 sets of jaws, and the only vise that I've ever seen that has a design like this. You can see that L-shaped track allows you to move the whole jaw body around. Now this rear collar also contains the screw and the nut. And I was having a little bit of trouble when I was screwing it together, and I thought maybe the threads were damaged, but it turns out that I think it was just more of an alignment issue. So I'm just sort of touching everything around and making sure that everything's going to work out, and then I bring it over to the downdraft table, and I'm using a single point wire wheel on a die grinder to get rid of all the rust and all the gunk that's in between the letters. Now, the rust removing soak removed pretty much everything, but it doesn't remove grease and oil. It's really not its job. So you have to kind of go back if you don't clean your parts thoroughly in advance and remove that stuff after the fact. That's okay though. It was quick work to get everything nice and cleaned up with that single point wheel. And I really like these single point wire wheels. I've shared these before. They're only about $12. This one is from Fair Abrasives, and you can get them, from a variety of different suppliers. But once you have one on a die grinder, I think you'll wind up using it more than you realize. It gets into hard to reach places, and you can see using a regular wire wheel can be a little more cumbersome, but it obviously is a little more efficient if you're using it on a large surface. So I'm just kind of brushing over everything, sort of getting it prepared for paint and making sure that I remove any sort of grease and grime. And then I'm going to move over to a Faired unitizing disc. This is a medium to hard unitizing disc, and what this does is essentially polishes the surface. This is like a tool and die maker style disc. It's kind of a soft material. That's a non-woven abrasive, and by using it on these machined parts, I can get basically like a mirrored on mirrored finish so that my vise base glides just effortlessly without even any grease. Now I'm using this on any of the contact surfaces, anywhere that 2 metal surfaces are going to be in friction, so that when I add a little bit of light 3-in-1 oil, this vise will just work flawlessly and perfectly. There's a little bit of tuning up that I had to do and some grinding and filing because I did find that the action was a little rough, but I'm not doing anything detrimental to the long-term health of the vise. I'm just sort of tuning up some of the rough castings. You have to imagine that this was cast, well over 100 years ago, and the technology that they had to cast a complicated shape like this wasn't necessarily perfect. So there are a lot of burrs and sharp corners, and by just taking a little grinder and cleaning up that casting, you can really bring one of these vices a long way in terms of just making it a little nicer. Now I'm kind of, again, just test assembling as I go, just making sure everything's going to fit together nicely. And you can see that if I screw on that back collar, I can have that rotatable jaw in place and just make sure that everything's going to function and swivel really well. I want this thing to work as though it's completely brand new and be really smooth and easy to use. Now I'm going to work a little bit out of sequence that I would normally do here because I'm waiting on some metric thread taps and some metric thread nuts and bolts so that I can bolt my jaws on later. So I'm going to actually prime and paint this vise kind of in the middle of the restoration. Now I want to tape off anywhere that I don't want to get paint on, and I'm just using this green frog tape. I like this much more than the blue painter's tape. I get it on Amazon and it's pretty inexpensive, much cheaper than getting it at a painting store. I use a Rust-Oleum self-etching primer, which is going to really do a lot for making sure that this paint sticks, because if there's any sort of little pinholes and stuff like that or any slick spots, I want to make sure that the paint sticks well. Now you see I removed some of my primer, and that exposes what I believe to be the original owner's name and date. Now someone at some point probably had this in a workshop and they signed their name J.M. Koch 1911. And I thought that's an important piece of history to keep preserved on this vise. So instead of painting over it with primer and paint, I decided to mask it off with some tape, and then I'll expose it at the end so that I can remember that this vise is over 100 years old and the name of the person who at one point must have owned it. Now I'm going to be using a hammered spray paint on this. I like the hammered paint on vices. It helps hide some of the scars and crimes that will inevitably come onto this vise from me using it in my workshop. And I just like the color as well. It's kind of like a grayish silvery color, and I just generally think it's nice. While that paint is drying, I did 3 coats of that. I went over back to the bench grinder and I used that on the threads for the main screw, just making sure that everything was nice and clean. And I also decided to clean off the handle. Now you don't want to paint the handle or the threads, obviously, so I'm going to actually leave that handle raw metal because it will get touched a lot and the paint will eventually rub off. Now the handle had a little bend in it and I didn't want to get it too hot, so I just put it over in the leg vise and gave it some persuasion with a bar, and I was able to get it nice and straight so that it worked perfectly. The screw also had a very slight bend in it, and I did my best to correct it cold using the vise. Now with the paint dry, I can put everything back on the bench and continue to work on this. One of the things I am going to have to do later in the video is remove the paint from the pins because those kind of triangular pin jaws aren't going to work with that paint on there. The fit is very tight. I'm using a 3-in-1 oil kind of all over this, just like a light oil, because I don't want to put too much grease on this. I found that when the parts are nice and smooth, you don't really need grease to smooth it out. You can use a 3-in-1 oil and you can actually let it soak into the metal a little bit, which will help just keep everything nice and lubricated. Again, just putting everything together and kind of getting myself situated, taking off my masking tape as I go. The paint job actually turned out really nice, and since I had to do so much work on this after the paint was already on there, I was able to kind of test its durability, and it really didn't scratch or get damaged at all, even though I had to do a bunch of more work to it after the paint was finished. Now you can kind of get a good idea of how that screw and nut interact with the back of that swiveling jaw. It's just 2 screws, and if you make them too tight, it basically seizes up the entire action. But what's cool is that as you tighten the lead screw, it'll actually tighten everything up. Now, one of the parts that was missing was a little shaft collar that I had to bore out on the lathe, which keeps the screw indexed and in place in the dynamic jaw. I was happy that this was the only thing that it needed, because sometimes the way that these screws are held in dynamic jaws on old vices can be really tricky, and this actually was a really easy and simple way to resolve that missing part. Now again, just using a little bit of oil and just kind of clamping it down to this Sigmund welding table as I go. Now, one of the things that it was missing aside from that shaft collar was this little brass pin. Now, I watched a video from Keith Rucker, from Vintage Machinery. He restored one of these and he had the pin. Basically, there are 3 little indents, kind of detents, in the dynamic and static jaw, and there's a pin that should have a spring pushing down into it, which keeps the jaws indexed into whatever orientation you may want to use. And it's not really that kind of permanent of an indexing. It's not like a clamp. It's really just to sort of keep it in place while you screw or unscrew the vise. So I made it out of brass, and I decided to just kind of cut it off with the lathe and tap it, get it nice and square, perfectly flat on one end. And I tapped it with a 1032 thread, so I could just use a little Allen key, a bolt in there. Now, once I had it off the lathe, I cut it down to the proper length, and then I just chucked it in a drill, and I ground it into sort of a rounded cone shape on the Merabraid 2x72 bench grinder. I cleaned it up with some Scotch-Brite, and then just kind of made it nice and smooth. Now, for my spring material, I found this in my shim stock, and you can see right there, I did a hardness test on it, and it's 52 Rockwell. So I know that it is a hardened shim material, and it's a nice thickness. I think it's about 0.30. It's going to make for a perfect spring here, not too heavy, but not too light. The only problem is when you have to machine and work on spring steel like this, that's this hard, it can be very hard on your tools. So I grabbed the small drill bit and I was able to punch one hole, but this material was just super hard. I did not have any carbide drill bits that could drill it, so I switched over to a small carbide burr and on my little rotary tool, and I ground out those holes so that I could fit a 1/4-20 screw on one side and a 1032 on the other. And then you can tell by the brightness of those sparks that this is a hardened material, and you cannot cut hardened material like this with a bandsaw or a hacksaw. You're going to want to use an angle grinder with a good cutoff wheel when you have to cut hardened material like this. Now you can kind of see the idea of this spring-loaded pin that's going to push downward. Now I wound up tinkering with this for quite a while. Originally I thought I wanted to have like a little lever on one end that I could lift up with my finger, but then I realized that most times I don't really want to have to interact with 2 hands, so I just actually wound up shortening it later on in the video, and I ground in some kind of little ramps on the side of those detents just so everything would work nice and smoothly. This took a lot of kind of fussing with, and I wound up remaking the pin and doing a couple of other things, but I did wind up getting it to work. Now, there's an interesting repair that was done to this vise by the previous owner, a gentleman named Chris, whose father was a maker, machinist, and restorer. He, I guess, had planned on restoring this vise, and he did a nickel braze or a nickel weld on that jaw. I think the jaw ledge must have snapped off, but he clearly never got a chance to put a jaw on it. So that's another reason why I am kind of really excited to be doing this restoration. It really brings me great pleasure to bring old tools back to life, especially one like this where I actually am in contact with the guy whose father this belonged to, and he'll be able to see this on my Instagram or on my YouTube and see that something that his dad had in his shop now has a new life and is going to get used and shared with people, and it's going to continue on and not just wind up in a scrap pile. So for this, I'm using some 3/8 mild steel, and I cut everything out. I laid it out with some layout fluid and then milled it down on the milling machine. I want this to be as precise as I can get it, and I just took a couple of quick passes to get down to the proper height and squared off. I kind of cleaned up the edges on the 2x72 grinder, and then I can bring it back over to the vise. Now what I'm going to want to do here is actually drill and tap for some screws. Now originally I believe that these were hardened jaws that were brazed on with sort of pins. So I've seen other photos of these vises, and what I found is there's no visible way to replace these jaws. And I don't know that they were brazed on as just a jaw, because a lot of them have 2 small holes in the back of the jaw. So I think what they did was they made hardened jaws that had some sort of an indexing pin that they could put through, and they could either braze that in or they could peen them over. Regardless, I have to deal with what I have, and I'm going to drill and tap so that this jaw could actually be removable, because I don't want to go and heat this up and risk cracking it or anything like that. Now lining it up, you can see there's some material sticking out over the side. That's okay. We're going to be able to cut that off. That shouldn't be a problem. And then we'll use a center punch to mark it out. Now I'm using this fine Versamag vise over on my drill press. It's really great because you can kind of set it to a middle tension and it'll sort of let you move the vise around. Then you can pull that lever and lock it in. If you haven't figured it out yet, Versamag, this is a magnetic based vise. So it's really a simple drill press vise, has a couple of nice unique features, but the fact that you can just magnet it down to any drill press table really makes it a super versatile and useful tool. Now, the way that I like to do vise jaws like this is there's not really a great way to clamp this, so I just sort of use my drill to get a impression, and then I can drill and tap one side, and then once that's drilled, tapped, and fastened, I'll move over onto the other side. I'm going to be tapping this with a 1032 flathead Allen keyed screw, and I'm just going to drill and tap this by hand using no real machinery. I did my best to get it square, and I think it worked out pretty well. I will say that anywhere that there was this sort of nickel braze or whatever the previous owner did to repair this jaw, I really had a hard time drilling and tapping. The nickel was extremely hard, so I had to be very careful not to break my tap off inside this. Once I hit the cast iron though, that was extremely soft and it was really easy to machine. So like I said, I got one side done, drilled, kind of used that as a clamp, then I was able to drill and tap the other side, and then I can go back to the drill press and use a nice countersink to make sure the heads of these screws don't interact with whatever material I'm going to be clamping. Again, using that fine vise to sort of get myself lined up perfectly, and then it gives you a really nice registration just to keep everything nice. I had almost forgot to drill my clearance hole on one side, but you can see that the countersink is sort of the perfect size. It doesn't bleed over the edge of the little jaw that I made, and it's going to fit really nicely after I go ahead and clean it up using a non-woven belt on the 2x72. So there you can see the vise clamped on. You can see how it's hanging over. We're going to cut that. Like I mentioned, the jaws on this side of the vise for some reason were cast offset, and I've looked into it. I've asked a few collectors and people that are knowledgeable. It doesn't seem like this was done intentionally. It looks like this was just maybe a factory second or something like that. And now I'm going to be working on the actual jaw alignment itself. Now you can see the original factory jaw is knurled, and while having a knurled vise jaw can be good, I actually prefer a smooth jaw because I just feel that anything I'm clamping, especially in a vise like this, I don't want to leave any impressions on it. And if I need a really heavy duty vise with knurled jaws, I'll use one of my heavy chipping vises, something that's a little more utility based, that's really going to grab and hold on tight. You can see I'm checking with a feeler gauge, and eventually I get a really good fit. Now these jaws are about 4 inches wide, and these would have been removable. You can see there are some holes, and the interesting thing about this is that those holes aren't threaded. So I believe at one point you could probably have bought jaws that had little stubs maybe brazed into them or soldered into them, and you could change them as you wanted and peen them over. What I found out here though was that the jaw that I had made for the other side was just a little tiny bit too thick, and it wasn't going to allow me to get a solid closure on those other jaws at the same time. Now, it might not seem important now, but you definitely want both of these sets of jaws on the vise to have the exact same clamping point. And you'll see later on in the video, there's actually an advertisement that I found when researching this vise that shows that you could use 2 sets of jaws to clamp something. So I found it worth my time and energy to go back and mill this jaw down just so that everything would be perfectly aligned, so that when you close the vise, all 3 sets of jaws close in the exact correct orientation with no major gaps. Now, nothing's going to be perfect, especially on something that was made so long ago, but I want to do my best to get it as close as humanly possible. So once that machined down, I clamp it back in with some screws. I noticed that I need to do just a little more finessing of the jaw, and what I found was working with this with the file was really difficult. You can see the color of the sparks and the quantity of the sparks coming off there. That's definitely a hardened jaw, so it's very hard on your files. Now I decided to put my pin and spring in so I could kind of check everything. You can see now that when I clamp this, it actually holds those 2 pieces of 1/4 inch brass, and then I'm going to use those existing holes to transfer some marks and drill for a M6 by 0.8 metric screw and thread. Now, the reason I went with a metric was because if I used a 1/4 which is sort of the closest size, it would have just been a little bit too large. And if I used anything smaller, I would not be able to get any thread in these existing holes. I considered doing a helical thread insert on these, but I thought it was a little too complicated, and I thought it easier to just move to a metric thread, which is a nice in-between size, slightly smaller than 1/4, but slightly larger than 1032, and it worked out pretty well. The only issue I had was I bought a kit on Amazon with a metric drill bit and the metric thread tap itself, and it was just really not a good drill bit, and it was really not a good tap. I think it was dull right out of the box, and it was pretty frustrating because obviously if I broke that tap, I would have been in trouble. And next time I'll spend a little more money and buy something of a little higher quality, and I'll get it from my friends over at KBC Tools. Now I went ahead and drilled these out using the dimple marks that I got through the back of the jaw. And I have to be cognizant here that those marks are actually on the back side of the jaw. So when I do my countersink, I had to flip them over. But you can see that little ledge, that little shelf in the fine Versamag vise is just super useful, especially when you're drilling into little pieces of plate like this. Again, I want these countersinks to be just perfect so that the heads of the screws are not protruding out and everything can be clamped well. And I really like brass jaws. I think they're the most forgiving, and I feel like they never mark up my work. If I'm grabbing something in a vise, a lot of times it's a sensitive part that I don't want to get marked up. Cleaning everything up over on the bench grinder, just giving a nice milled finish, nice even lines, and cleaning up all those sharp edges to make sure this isn't going to damage or scratch anything. I'm using these stainless M6 flathead screws to get everything nice and tight. Now you can really see this vise starting to come together. I really like the contrast of the brass with the hammered paint as well. Now I have to do a little adjusting to the back screw nut, but you can see now both of the jaws close perfectly, and the last thing I need to do is a little bit of work to the pin jaws. Now you can see these triangular jaws. These are really cool, and a lot of times these vices don't come with those. But luckily, the gentleman I bought this from had a couple of sets in a few different pieces of material. So I'm going ahead and just taking a wire wheel and removing the paint from there so that these will fit a little bit easier. The paint built up and made it a little too tight. And then I'm just going to take a grinder and just do a little bit of adjusting to the neck of that pin jaw so that it doesn't stop the other jaws from closing precisely where I want them to. Again, a little bit of grinding isn't going to hurt anything, and it's going to just make this thing functionally that much better. You can see the functionality of that little pin that I put in, and it's working really well. Now I need to put in the pivot lock screw and oil everything up, but before I reassemble the vise, I want to color the letters that were cast into it with a gold paint marker. I always like this. It just sort of kind of sets off the vise a little bit and highlights the fact that it was made in America from the Emmert Manufacturing Company in Pennsylvania, patented May of 1903. It's incredible that this thing has survived as long as it has. Now I'll set it down there, and I was watching Keith Ruckers' video and I noticed that he had this double nut set up to lock in that swivel lock vise. So I actually just took a nut and cut it in half because two would have sticked out and it looked pretty terrible. So just cut a nut in half and then flipped it over so that the threads would interact correctly, and then I could lock them in place, and there's your swivel base swivel lock. Now to kind of set it off, I took off that masking and you can see the name J.M. Koch 1911. This thing is going to be used for many years to come, and I'm really glad to be able to honor it by having this gentleman's name. Now you can see I have a couple different types of swivel vise jaws for the pin, and now you can really see the adjustability of a vise like this. You can pivot it, you can move it, you can really use that L-shaped channel to your advantage to be able to grab whatever you need to grab at any angle, anytime. And I really like these jaws because if you've watched my previous restoration of a swivel jaw vise, these essentially do the same thing, but now you can do it at multiple different angles, and I could even make my own jaws for specific needs. And there's that double jaw grab that I mentioned earlier, which is shown in the brochure. Overall, I'm super thrilled with how this came out. Thanks so much for watching. Be sure to follow me on Instagram at MakeEverythingShop, and thank you to WD-40 for sponsoring this video. See you on the next one.